Hello and welcome to a new session of Hitchhiker's Guide to the Glamorous World, in which we are talking with newcomers to Glamorous Toolkit and Moldable Development. And today I'm joined here by Andrea, who is a recent enthusiast of Glamorous Toolkit and Moldable Development. And well, welcome, Andrea.
Hello, Tudor. Thank you for organizing this.
Nice to meet you. We typically start these sessions by just asking the newcomers, what do you think Glamorous Toolkit is? Or what is Glamorous Toolkit for you?
For me, Glamorous Toolkit has been something that sort of like a gatekeeper to see into the code. So to extract information from the code and make it available in new ways, let's say. I wrote it before in the Discord channel that something that really makes me sort of laugh. It's an ironic thing. This idea that you spend so much time trying to understand reality, compact it in a few lines of code, and then it's gone, lost forever, unless you have a programmer that tells you and explain, okay, this code means that. And it was probably like a surprise when I was hearing one of your talks in which you were saying, look, software is structured text, so you should be able to pull out information and visualize it So all of a sudden I look at a Glamorous Toolkit as this tool in which you can open a word that at the moment is just all encoded and cryptic, good for the machine, and for programmers.
So very cool.
Yeah. Thanks.
So let's start with the questions. What would you like to know?
Okay. Yeah. So So first, the main thing that I would like to understand is how do you actually use Glamorous Toolkit to produce code? What I'm using now is, okay, I get a requirement. I am a software engineer, right? So I get a requirement, say, the word works like this, and our users really would like to get this value. So I get these requirements, and my target, my aim as a software engineering is to provide this value to the user. But in the process, I have to speak with business people, I have to speak with other developers, with operation engineers. So if I manage to make this code explain itself to different audiences, I will get an advantage because I will be able to get more feedback from each of these people. Only that so far I'm educated to just produce the value for the user. So my question is, okay, how should I use Glamorous Toolkit, but in general moldable development, to switch my frame of mind from just deliver the value into make it explainable, my software, while I develop it.
Mm-hmm. So that's an interesting point. There is no single answer to that, but what we have found to work quite well is something we call demo-driven development. In that, when we think about, like you think about what is the future, like what is the future feature, how is that described? Very often it's described in terms of the system should do that, right? Like you have this kind of famous as I want to do blah 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 something. And it's very dry, right? And one of the things you see at the end, right? It's direct at the very end when people demo their systems. You tend to see there that demos are not atypically, they go like this, like, oh, so the requirement or the user story or however the name is says that if I go here and I click here, I should get that. So I'm going here and I'm clicking here. Oh, look, I get that. Good. Questions? And then there's no question. Like nothing happens. Like there's just Okay, and then the next one comes, and then the next one, and then the next one, next one. And so all of these things then afterwards are very, very dry at the end. And so at the end, right, the whole point of those presentations is so that you can get feedback. But then there's very little feedback that happens in practice. So then the question is it possible that like what's it for? if you're just doing it, but then you don't get any feedback, then what's it for? So now, of course, like how do you get feedback? Well, first of all, you have to get people interested. So usually stories, like not the user stories, but the stories behind the user stories. Like usually, it's fascinating because user stories were mostly about the stories that the user would talk about, right? And they came like in contrast to use cases, which were technical specifications of what should happen. And but now we templated the user story only so that they become this boring specification at the end. And then of course, like the systems can provide it, but at the end, it's still boring. So, but now, so what will make it interesting? What will make it interesting is that at the end of it, you want to see a story. But now, the interesting thing here is that who should tell the story? Because when you're demoing, it's like you can't be the one, talking. You're not the one telling the story. It's the system that tells the story. And there's a very interesting thing that people can watch for during a demo session. You can watch for can the presenter do both demo and talk at the same time? Can you demo and talk at the same time? Because normally you're not really able to talk about two divergent things. And you have to. So then you will see that people will either click or talk, but they won't be able to do it quite at the same time. And the main reason for that is because the two things are actually distinct. So the story that you would think, wow, this is what would animate people, is actually not tellable with the system. And so then the question is, how do you transform that? So then you say, well, okay, if it's the system and it's not me that should tell the story, if it's the system should carry my story, and then I will see if I can speak and click at the same time, because if those things are the same, then I will be able to do it. But if it's a system that has to carry that story forward, it means that I have to design it in the system. It means that the story is not being presented after I have built the system, and it comes before I built the system, right? So then it goes all the way at the beginning. So then we don't talk about, in fact, about specifications at all. We just talk about how should the demo look like. So that's a simple change that people can make, and it requires no tooling. Just this. Talk with the business or whoever, with other stakeholders, not in terms of what the system should do, but what should the demo be like. And then all of a sudden, all sorts of things can follow from it. Now, of course, this is just about, most demos, they just focus on what people see, like what a user would see from the outside of the system. But of course, like any interface, any interface in a software system defines a boundary, but any boundary in a software system is arbitrary. So, like if I'm just working with an API that an end user will never see in practice, the API is my interface now, and that's what I will have to work with. So I am, even if I'm a developer and I'm going to work with that API, in that case, that is the interface for me, and it's not just the interface that I see that an end user would see when you download an app and play with it. So from that perspective, it means that if I can make something explainable, if I can make some humans understand some parts of the computation, well, it probably means that I can do similar things to all other humans and to all other parts of the computation. And we can apply the same principles everywhere. And that's pretty much what moldable development is. So why these all large parentheses here? So let's maybe I give you it's a demo that I'm giving now very often recently. This is actually a domain. So in this case, we have a cozy corner, a room, a table 1, table 2, and a kitchen. And we actually want to see how should this waiter and the cook, for example, that are associated with different parts, how will they communicate with one another? So this is now something that we talk about, from a business perspective, right? We look at this from a business perspective. And and now we say, okay, like this now, John Waiter over here, the way we want to do it is, places an order. This order has a way to propagate. And at some point, there's some logic that will transform it into some other message that propagates in some other way and finds Jeff Cook. And then at some point, Jeff Cook, after the cook is, the meal is finished, Jeff Cook says somebody should come and deliver it. And this message finds its way all the way to the waiter. So this is like a wish, right? This is a story that we would like to tell. And this is what we have drawn. Of course, like we can go and look into the specifications and everything, but it's very important that there's a scenario, like this is how we want things to work. Now, here's the interesting thing. The question is, how would you demo this, right? And so normally you would have two devices here, right? You would say, okay, there's the device of the waiter and there's the device of the cook. And so when the waiter can go and click, and then you place the order, and then the order should appear on the device of the cook. And at some point, the cook should say somebody should come and deliver it, and then that message should appear on the device of the waiter. So you'll have two devices, right? And that's all interesting, right? And pretty much all demos, they focus on that level. But as I said, every aspect in this, like every boundary in the software system is arbitrary, which means that we should be able to tell this story, like a similar story, interesting story, but about the stuff that users will never see. Because that's what the user will see. The user will see who has some things on the to-do, right? So at the beginning, Jeff Cook had an item on the to-do when he had to cook it. And now at the end, John Waiter has an item on the to-do because he has to deliver it. So, and that's interesting, right? That's the only thing you see. But you will never see the lines. Now that's interesting, right? Because the lines are not visible, but they are so essential. They are, because that's exactly what makes this specific implementation interesting. And so now what we are saying is, well, how are we going to talk about this? How do we draw the lines? And we have to go to where the lines are. Now, where are those lines? Well, they are inside the system. They are not outside the system. And so again, like the same principles, but we go and apply it to everywhere. So, so here, for example, I've implemented something, a model. You see here, you have a venue, and then you have a kitchen in the venue, and then you have a room in the venue, and then you have two tables in the room, and the waiter at the tables, and the cook in the kitchen. Okay. So if I look at these ones, I kind of squint, I can kind of see the graph that I draw before, right? I can see, okay, the venue includes a kitchen and a room and the tables, right? But if I do this, I don't have to squint, right? It's just, here's the venue, here's the presentation, and now it tells me a story, right? Okay, and then I said, I also talk about something like a computation, and that's because these little nodes over here, they actually have computation associated to them. So like in this case, we're actually using Faro as a computation language. So you can actually play with this. But the more interesting was the lines, right? So here we're going to simulate what happens when John Waiter places an order at table 1. And so here we see it placed the order and then goes all the way to the cook, right? And now the cook has an item on the to-do, right? So now if I click here and I say, well, what happens now? It goes all the way to the waiter. And now the waiter has an item on the to-do. So I just told you a story. But this is a story. This is a story that the user will never see. In fact, this is a story that we can tell way before there even is an interface. And this is a story that we can tell about the somewhere deep. In fact, this is one of the most, the most central pieces in this whole system. Right? It's like the correspondent of, you take a car and then you open the hood and then you take the engine and then you open that engine and then you take some piece out of the engine, you show it to somebody and says, oh yeah, I understand what that is. That's the same thing that we've just done here. But just look at some arbitrary object. here some object. And then this object, with these objects, we can tell a story. So now what's interesting about this is that one of the things that we're doing with, for example, with companies is we're helping them tell stories about their own systems, sometimes before there even is a system. For example, with startups, we help them pitch investors with just by concatenating a few object inspectors together and telling stories about the inside of their systems. But the interesting part here is that these stories are actually understandable by non-technical people, which is something that is quite difficult to imagine, right? Because you were talking about it at the very beginning about this problem of this knowledge being just packaged there by somebody or compressed in some way and encoded and encrypted in this program that maybe, if you're lucky, some programmers can understand, but nobody else can, right? But then it has impact on everybody around that system. It has impact on all the stakeholders. It has impact on the customers. Everybody is impacted by whatever decisions these encryptors have made, but very few have a chance of saying something about that. So that's just how we are seeing it. So what just happened here is, like what you're seeing here on the right, this is nothing but just an inspector over an object, which is normally seeing just variables and values. But in our case, we took a little bit of time and we could build a little visualization that actually helps us tell a story about this. Now, of course, once you're doing something like this, then you can also go and describe this. You can also go and describe the story in other forms, right? Not all of them have to be interactive and from a programmer perspective. So this is a live document here, which is basically telling the same story. So I can go and play with this and see what happens. But this is consumable with no knowledge about and with no exposure to programming, because there is no need to be right. So anything can be packaged together and then presented in some form. And for example, a document is nothing but a mechanism for deploying a user interface. And that's basically what we're saying here. And so now, where does this view come from? Because before it came from a playground where I had some objects over here that I executed, that I constructed and I executed maybe some code, and then at the end I'm inspecting something. And that's how this visualization is being created. So where does this one now come from? Well, it comes from an example. So an example is a way of, if I go and look at this, this is pretty much doing kind of the same thing. So this is a cozy corner creation. I can look at how it's created. And I will see over here all sorts of pretty much the same thing that I saw before. You see John Waiter and so on, and the cook. And so kind of things that I saw before, but constructing now as an example. And an example in this case is like a test. So I set up something, I execute the behavior that I'm interested in. In this case is this one, so placing an order. And then I'm asserting something. So up to here, it's pretty much like a unit test, except that in our case, we're returning something. So if you think about a normal unit test is interesting as long as it's red, right? So like people just look at the unit test pretty much when it's red, right? So because that's, and then as soon as it becomes green, we don't care about it anymore. That's it, it's done, right? Yeah. Because the test methods are void, right? They don't return anything. But just by making that test method or example, return some object. In this case, it's the object that I went through such a trouble of creating and then ensuring that it has these interesting properties, right? If I'm returning it, that's it. And now I'm combining this with this extra view. I basically can create executable documentation, executable narratives about my system. So this is why, right, this thing with Glamorous Toolkit is an environment where we're taking all these ideas to the some people can say to the extreme, but we're looking at the other way around. We're just saying we started from scratch and asked the questions. What is the property? What properties do we want at the end? And then we just build the logical consequences of that. And we said we want to be able to tell stories about any part of the system. And we say, why do we want to tell stories about any part of the system? Because stories are the ones that will get people to be able to relate to some technical part. And why about any part of the system? Because we should not be judging just by the cover. We have to go inside the system, because it's the way the system works is interesting today, but the way it's going to work tomorrow depends very much on our ability to change it. And that's not a function of how it works, it's a function of how it's structured. So you have to actually go inside that box to have a chance of doing this. So we wanted to be able to tell stories about any part of the system. And as a consequence, we ended up with something like this. So in the process, on the one hand, we have these inspectors. So this whole idea of moldability, multiple different projections about anything. And of course, we started from the inspectors, but we also have this live documentation, which are there. We've also modified how we are constructing tests, because it just didn't make sense for those to be a separate concept. So in this case, right? So there are multiple pieces of a puzzle that kind of fit together. But this is basically pretty much how it works. It starts from here. You'll pretty much always start from the playground. So Smalltalk, if you're programming Smalltalk with Glamorous Toolkit. So Smalltalk is a live system. And a live system should be programmed in the presence of self. You want to be, when you're writing a line of code, you want to have values available. You should, because when you're going into a static code editor, you're assuming, right? You're taking the general perspective of the world, right? You don't have a specific context. You have a static one that will encompass all specific contexts. But that's a dramatic generalization step. And there are other environments which are maybe more equipped for that. For example, those that provide you with static types and so on. But we are in a dynamic environment where we focus and we favor the ability to change the system at runtime, and maybe in inconsistent ways even. So in that situation, we don't want to compete with a static language. In the static world, we want to go and program on the dynamic side of things. So this is why we are programming pretty much all the time in the inspector and playground, and maybe in the debugger from time to time, and not so much in the editor, and in the static editor. So you always start from here, then you're transforming those into examples, and then you're composing stories like that. Does it address the question somehow?
Yeah, it helps a lot. But yeah, for example, for me as a developer, I'm much more familiar with the example part. So imagine like when I am working with a product owner, with somebody from business, I typically say, okay, what do you have in mind? Tell me the reality as you see it. And I'm going to make little examples, so to validate your view of reality. And so that is a lot of time helping a lot in finding corner cases, little stories that are atypical. They're not following the happy flow, let's say. And so with the examples, I feel familiar. So, okay, what I will do is, if as a Smalltalk developer, I will create my sort of unit test, but I will return a value. And now I have something I can embed in my documentation. When instead you are doing the graph with the arrows, now my audience is slightly different, because maybe that will not hit, like now I am a bit out of my water, because it seems to me that now I need to be addressing, making a story that is not anymore just for business. It's maybe also for an architect, or also, there is a different audience. And as a developer, I need to be ready to adjust my exposition to them, or to create views that address them. And that is the thing that I feel a bit out of my, it's like a bit a fish out of there, because now to an architect, I can maybe have a chat colloquial and do a couple of boxes and say, look, this is how I think my software works. but now I need to, you understand, like it's a sort of funny because now I need to think in a way to explain to them with a nice soft knowledge extraction from my software and put it in a nice in a form that they understand. For example, the box that you are showing, the EU place order, that is something that me as an architect, I will say, yes, I understand the data flow here, or the and as a developer, I feel like, oh my god, what's it? It seems like a new job, a new job function. You know, like it's something I'm not prepared. So how did you pick up this? How did you start? Let's say I understand the question, how should I demo it? But I am used to say how should I make this work? Now all of a sudden I need to transition in how should I make this easy to get. And I wonder if you have some tips for for this.
Well, so that's a very interesting question. So in fact, there were a couple of questions. So one of them is, so one of the questions was, if I understood correctly, one of the questions was, where do you start from now that you have to tell this story? How do you put yourself, like, how do you know what they will want, for example, and how do you know how to translate this to that? And we kind of do the other way around. Like when I said here, it's quite important. This is something we drew on the whiteboard. This is what you say is like that thing that you have drawn, that you were saying, oh, here are a couple of boxes, here how they will look like, right? And so this is what we draw typically before we start. That's like we sketch how things are gonna look like, or how we think they're gonna look like. But as soon as a human deems a specific presentation, a specific way of translating that computation into something that is perceived to be understandable, we are saying, well, it's the responsibility of the system to carry that representation forward. So if you look at this one, for example, right? So here we kind of like maybe drawn by hand. We did draw this something like that by hand. But after this, right, it's not exactly the same. So it's not 3D, for example. But most of the things are there, right? It's still recognizable as a presentation. And in fact, it started like this. The reason we built this was because we just wanted to debug the algorithm. And every time, so we didn't build it with an audience in mind. We built it with us in mind. We drew it. We drew this thing for us. This is how it should look like. And then we said, okay, let's see. And then we wrote some tests, right? And that test kind of worked. So the assertions were correct, but I still wanted to see the same presentation as I drew on a whiteboard. That's the principle. That's it. It's not that difficult, and it's understandable that this is uncomfortable, and it is a new skill that is implied here. But it's not much different from how it's uncomfortable to learn how to write tests and not just code, right? So write tests and code and not just code. That's uncomfortable too, right? Because you say, oh, now I have to think about how do I write the test, and then I have to think about the code, and I was just so used to just writing the code. It's already difficult enough, right? But then it turns out that it doesn't have to be more difficult, right? It's a different way of using your energy, indeed, but it's not even more expensive, and it doesn't have to be more difficult. In fact, it's less difficult. And the same thing happens here. The principle that we're using is that we're gonna every time we find ourselves like cringing, something's wrong. Like we are missing a view. It's that simple. And we're going to just stop and say, what am I missing here? Why am I not relaxed when I look at this problem? And as long as I will not be relaxed, I will just continue to build those tools. And then, of course, now people are talking about, shaving yaks and going down the rabbit holes and like how you shouldn't do that because it's like a waste. We find that the waste happens the other way around. The waste happens when people don't understand what is it that they need to solve, how, what the impact is going to be of what they need to solve. Those are much more wasteful things, much more wasteful activities than this. So yeah, that's how we are doing it. Now, how do you learn it? Well, you start doing it.
Okay, it's very practical. Yeah.
Yeah. And then
Cool.
and we built, it's again, like we started talking about this, or I started talking about this about 12 years ago or so. But nobody really listened. And so we built Glamorous Toolkit just so that it's very practical. Like we don't have to talk philosophy if you don't want to. The goal is philosophical indeed, but we don't have to talk philosophy. Like this is something very pragmatic. People can take and use and apply it on certain use cases, and it just works. So like we could just start like that, because people didn't pay attention to the philosophical things because you were just too far away from what they were doing on a day-to-day basis. So we made it much more practical. And in fact, Glamorous Toolkit is itself a system that built from the ground up, um, following moldable development. So there's lots of little stories that we can tell about the system itself, because we told these stories among each other in our team.
Very cool. Yep.
So the way it works. So here's a presentation about moldable development. It pretty much goes like this. Every time I have a question about the system, I'm going to apply an analysis. I'm going to take these results and I'm going to do something with that. Right. So if I have a bug, I'm going to say, oh, I'm going to find where the problem is. And then when I'm confident, I'm going to go and fix the problem the way I think it should be fixed. Right. But then the question is, but the same thing happens when I have, I don't know, I need to split two pieces of a system, or the system into two. Then in that case, I'm not going to look at the functionality. I'm going to look at the structure in that case. It's a different piece of data, but the process is exactly the same. It's interesting how people are actually splitting, thinking about architecture versus thinking about functionality as if they are two very different worlds, and we think they are not. But that's also why we have strived to be able to accommodate both of those kinds of worlds in the same environment, just to show that they are not actually that different. But the key challenge here, this is not really that new because this is pretty much the scientific method. But the key interesting point, observation about software systems, is that software is highly contextual. And because it's highly contextual, we can't predict your specific questions. We can only predict classes of questions that you might have, but we can't predict specific questions that you will have. We don't know exactly what bug you will have. We know that you'll have bugs. You can even say what kind of bugs you'll have, but not the actual bugs, right? And as a consequence, we can't give you a specific exact analysis that will give you exact answers to your questions. Right? And this is why before we have this question, before we apply an analysis, it's so important that we stop and we say, well, actually, do I have an appropriate analysis for my hypothesis? And if I don't have an appropriate analysis for my hypothesis, I should go and build it. So that's what we do. That's the little exercise we interject. And when you're doing this, let's say when you see a long text file, right, then you start scrolling through it, there should be a little buzzer associated into the mouse, right? And every time you start dragging and scrolling, it should be little tiny impulse, because it should remind you, say, well, are you using the right tool now? Because when you're scrolling, you're actually using your eyes as a data mining tool, and might not be the most appropriate thing to do. So anyway, that's it. It's really not that complicated. It takes a while to figure it out. It takes a while to for it to get comfortable, but it's really not that complicated. And now what's interesting also about this representation is that there actually are two roles. So for every one of those kinds of problems that we want to decide about, for every one of these, there are two roles. There's the role that formulates the question, and then there is a role that builds the tool. And those are really distinct. They are not the same. And you want to train them differently. And it might, what we find is it's very often the case that it's actually easier if you have two people, like a pair, working on the same problem, one owning the question and the decision, and one owning the tool building, because you have to work at two different meta levels. And so it might not be so comfortable doing it alone, especially at the beginning. But with that in mind, it's absolutely possible. It's just, it takes a bit of time. And we see in practice, it can be organized. And anyway, like not everybody will learn how to build these custom tools. So for example, if you have a team of 10 people, it's also practical to start from just one person learning how to build custom tools and then supporting everybody else in this process.
Yeah. Yeah, makes sense. We at work we do sort of backends also, because testing, as you were saying before, is the same. Like sometimes you really need to have that mind frame just to test your software rather than thinking about the requirements or the implementation. Or so yeah, I get the tooling. Yeah, it is something completely different. Okay, thanks. Yeah, that is helpful. Sort of clarify. So basically, you to summarize is you build the tools for yourself. So you have a feature that you want to implement. You have some problem with it. Say, okay, you know what? There would be a better approach to visualize this issue. Let me build a tool that makes my life easy, and then automatically this will generate value also for other audiences and make your system.
It might. But it's also like if you when you don't have to imagine too much, right? You can imagine it for yourself because you're the one that says, oh, I kind of would like to have this presentation. See how it works. But then for the other ones, very often they will actually draw it for you. You just have to pay attention what they drew on the whiteboard, because that's pretty much it. That will tell you what kind of presentations they will want.
Okay. But you don't actively. No, do you actively look for it? So in the sense that you say, look, I want to make my system explainable to this person. So let me see how it's drawing, or let me see what slides or whatever, and say, okay, now I'm going to make it automatic. This is what you...
Yeah.
Okay, I understand.
Very often. Sometimes, of course, it's like with UI design, right? First, you're listening. When you're at the first stages, you're going to listen to your users and they will draw it for you. But then at some point, you'll transcend that and they'll say, well, I kind of listened to what you're saying and maybe this kind of presentation would be useful for you. But it's really not that complicated, really.
Yeah, it's just, I'm asking like this because I'm probably curious. In the sense that, for example, for some work that I've done, I had a question similar, but I think I get what you mean, because I was implementing like a sorting of some objects, let's say, and this sorting was a bit clunky. You needed to have different scores that together, summed together, were providing the final score. And now our business cared about these components.
Mm-hmm.
And so it made me laugh because you were saying something in one of the talk that you gave, like don't use toString. Then I ended up doing toString because I basically put this all these components of the score in a string that say, okay, this is your final score, and this is component 1, component 2. You business judge if this is what you expect.
Yeah.
No, but it was a string, and then they didn't like it as a string, and so our front-ender created a mock in which this string was adjusted. No, and so it makes me laugh because it's actually
that's it, right? And you want to have business people. So, for example, right when I was showing you this, let's see if we can find it again. So here, right, we just talk about how prices are composed here. Simple thing, but it's a computation. It's a computation of like it's a description of an algorithm. Like how do you add, for example, discount, right? I have a discount here of 100 euros, and then I take 10% off, and I have 90 euros. It's one of those like simple operations that again, like a user will never see. A user will always see the end result, pretty much. But not these pieces, right? So if I now go here more, in more complicated type of scenarios, then I'll get there are more like you can have conversations with the business in a way that otherwise you can't. And now, who drew this kind of presentation? the business, they drew these kind of things, right? And they want this presentation. They just give it to them.
Yeah. So it's very fantastic. So in my mind, this link with a lot of things, like this idea of don't do anything, listen. It's also one of the principles of permaculture, no? That is like don't modify your environment, see how it behaves, and then you find a strategy. Same for the houses. They suggest don't adjust the design inside the house before you live in it, because maybe you like the window with the sun, and you want to put there the sofa, not that you build a kitchen in that place and then you would like to spend your time reading the newspaper there, for example. No? So
Yeah.
This is again an example of that. So see how they draw, how they want to express the business information, and then from there you produce a view yeah.
And the same thing applies to architecture, right? Similar things, except that sometimes you will find that, for example, data science is slightly different, right? So what you learn from data science is that there you're using, the data scientists will use the presentations as a tool to actually figure out what the relationships are, what's the right thing to infer from a certain piece of data. And same thing applies here. So sometimes we just create tools that we actually throw away, like nobody will ever see them. We don't reuse them. We just create them, use them for 30 seconds, and I said, nah. Or maybe, yeah, I liked something from it. I like this. I'm going to do something with it. But I'm going to just create lots and lots of tools, many tools per day. And that's how we decompose the problem. So you asked there was another question, was like, where does this all started from? Well, it started from this little realization that so developers spend all of this amount of time reading code, and I was doing research at the time, and still am doing research, but just not in academia. And I was writing papers, and those papers were all starting with this thing with saying developers spend 50% of their time reading code. But the oldest reference about this was dated back to 1979 that I know. And then it just hit me. It's like, what did we do for 30 years? This was in 2009 or so. Right? Because like if they're still reading, then is it possible that we are just solving the wrong problem, or we don't know how to formulate the question properly? And so now I'm convinced that we didn't know, or I didn't know. And this is where moldable development came from. It came from just trying to say, okay, let's actually go and see in practice and doing solving industrial problems and trying to use tools that would then do some replacement of the reading. And then the only repeatable thing that I found was, originally I thought, well, I will be creating, I just don't know exactly which magic buttons to give people, but so I'll be just doing some consulting, and then I'll find the magic button, I'll give them the magic button, they'll make them immediately happier. And then it turned out that the only repeatable thing was that there was no repeatable thing. The only repeatable thing was that I had to tweak my tools. If I wanted to have a chance of being remotely relevant to their specific problems, I had to tweak the tools. And that's where moldable development came from. Because then we said, well, what if that's the thing?
Yeah.
What if the context is the most important? So when the context is the most important, then I cannot assume what your problem is going to be. So then I won't.
Yeah. Something make it. Yeah, it remembers me. There is an anthropologist, a very famous anthropologist in Italy that it's sort of ironic as well. So what he says is, look, in Florence during the Renaissance, there were very few people that managed to change the world, and we still have these beautiful ideas, paintings, like all sort of the most beautiful things that we could conceive 1,000 people, 1,400 people, they managed to. So I was saying, what is the secret? Because if you think about now, like companies like Google, Apple, in a building, they have more than 1,000 people. So potentially they should be able to. And one possible explanation was that they had their own time. So they had their own independent way to share information with the people that were the most fit at the time. And I think I'd say like you are at your house and you know that there is the shoemaker next to you and say, oh look, if I compose the shoe with my hand making thing, I can make a piece of art. And so they will find a way to chat together. And maybe it's exactly this. Sometimes it clicks in my mind that moldable development could be a way to make this information available and find finally like interaction between business developers. Not that that what I created can be very accessible to somebody else because I express it in a way that they understand, and so the feedback loop becomes much quicker. And but yeah, anyway, it was yeah. It just sometimes I get these clicks, say, but this actually seems to have a similarity with. But anyway, yeah, it seems quite quite an interesting approach. As a developer, I really like the idea that I could make more accessible, spend some of my time to facilitate others into understanding. But then also the question is, how do I do it long term? You know, like one thing I'm worried about is that when I leave an organization, and for example, I was responsible for a piece of software, that I have become the only owner of that software. It happened in my career, and I see it happening that some software, or little by little, becomes legacy and basically living by itself, becoming a planet all by itself, and then you create a wrapper around it and say, don't touch it. But if I am one of these maintainers, you said that the views that you can create depend on the context, but how can I make sure that I leave an ecosystem of this software that is very approachable from future generation of developers or business people? Do you think like I can use Glamorous Toolkit or Moldable Development to say, look, if you come from nowhere, these are the even if the context of yours will be very different from mine, these views can help you. So sort of like, there were some artists that were painting, I think they actually implemented for nuclear waste. They sort of imagine, okay, in centuries, how are we going to say to our future generation, don't go in that place because otherwise you get poisoned? And so they were coming up with figures of very, spiky, and you say that for a human, even if you don't have any context, you say, okay, I don't want to touch that because it's very, could we do something like that? I understand that the views are contextual, but how can I guarantee? How can I?
Well, yeah. Can you guarantee? No, you can't guarantee. Can you make it more likely? Yes, you can. So, like for example, in the case that I just showed you, right, with the prices or with the restaurant, those are examples of just some of the stories that we can tell. But there are others. Like, so if we look now, let's quickly check here. So if I go back here, I'm going to open another playground here. Like a view is introduced through it's introduced through a pragma. So pragma is an annotation in Faro. So if I'm now going to check for, which is called GT view, this is how a view is. So a view is like a two-string method or a print string method, but it's instead of a string is a widget, and instead of just having one, you have many. So we have to go and find them by annotating them in some way. So this is how we annotate them. And of course, those are going to be methods that are implemented in the class of the object that we want to visualize at the moment. So if I write this, if I query this, I'm going to get all these extensions over here, right? So, and this is now a method implemented, for example, in abstract reference. So in the file reference, if I'm inspecting a file and the file has a JSON extension, then I'll be showing a JSON style editor there. So, right, that's what we see here. Okay, now, if we go back here, there are 1,500 different such views in the system that I'm just showing you right now. So 1,500 different plugins, right, or extensions. And then you just look at those. It means that there are at least 1,500 different stories that we tell. But what's interesting is when you start to have a combination of those views. Just to give you an example, and I like to take this. Like I say, I want to tell you what kind of what kind of shortcuts are implemented in this editor over here. Right, which is typically a question that we get asked by people that just come into GT. So here I'm now pressing Control Option Shift, and if I click on that, I'm going to now go to in an inspector over the scene. We call it the scene driller, right? And it shows me here in the left-hand side, you have the rendering tree. So it's kind of like the DOM, if you want, right? But in our case, even a single element in the text has a such a thing. So if I look here, let's unselect here. Then if I click on this one, this element is also an element, right? In fact, the cursor is going to be an element as well. So, so if I have this one and I go and let's find the editor over here. So I see source code editor element, right? And now I'm double clicking on that just because I want to see, and I go and inspect now. So I went from one level, I think one story, and now I'm diving into that one, right? And now this one will going to tell me, okay, I want to find out, can I see what kind of shortcuts are available, right? And if I scroll through these, I can find, oh, look, there are shortcuts over here. So now I can see the shortcuts, right? So okay, that's an interesting thing. And then of course I can also take a look at, what kind of, measurements have been applied to this. If I'm doing a layout debugging, I'm going to be interested in this. If I want to find out what shortcuts are, I'm going to be interested in this. So two different stories, right? But now I want a next step, right? Let's say I'm not just interested in where this shortcut is implemented. I want to find out how I can change it or copy from it. And so now if I click on this one, I'm going to get a shortcut, and the shortcut can tell me the source code. And I can go now and browse this one because look, this looks like a class. And I'm going to browse this class, and I'm in the context of this class. So the thing, what I wanted to show you here is that when we say 1,500 extensions, they are not just 1,500 stories that we can tell. These are just the operators with which we can construct stories. But the stories we can construct are many, like they're not just linearly larger. They grow super linearly with every new presentation you add, any new view you add grows significantly the kinds of stories you can tell about the system, right? And so here we actually reason about the system without even looking at the source code, but we still traversed the system in some other ways. And that's the interesting thing. That's the power. That's why when we look at Glamorous Toolkit, we designed it not as a tool with features. We designed the environment as a language made out of operators, interactive and visual operators, that we can then combine in many different ways to accommodate many different kinds of contexts. So that's why this thing works, because with every new little thing you add, and all these stories, all these views are very simplistic. In fact, if you go back now, and we go to how many stories there are 1,500, and then the average line of code here is 12. So if you take away the the header and the pragma line, you basically have 10 lines of actual code. So in 10 lines of actual code, there's very little things you can tell with, like, because you cannot create very, very complicated things. But it's every one of them is not interesting, or it's very little interesting in only limited ways. But when you start combining them and seeing them as operators, and the environment allows you to combine them when you want to, then all of a sudden they become much more valuable. Now,
I understand. Basically, it's the accessibility also that there are multiple things here, right? Because you make a lot of views accessible, you make them composable, and the environment itself is prone to your error. No, because I don't know Glamorous Toolkit very well, so I can start just playing around, breaking things and stuff, but it's an image, so I can just throw away the image, start again. So that is also a freedom that I have, is I can experiment without being afraid that, I touch this and everything crashes and cannot use it anymore. So that is also, there are multiple,
And then, but so up to now, we still talked about, so these views, they are already being created and we're using them, like they have been created already. But the question is, how were they created, right? That's the other thing. Some of these views are actually created on top of code that exists maybe since 20 years. So part of, so half of Glamorous Toolkit comes from Faro. Glamorous Toolkit has just we've just redone the whole graphical environment, plus the tooling and the analysis of external various kinds of engines for both analysis, documentation, visualization. But the core of the language and the runtime actually come from Faro. So, and there are classes there that exist since a long time. But these views that we have created are much newer than that. And so that's the interesting thing, is that explainability is not like, is not just a writer's problem. It's also a reader's problem. It's like the same as with a book, right? So if you take a book and different people will understand different things from the book, depending on how they read the book, and also depending on what they know already. But but the way you read the book can change what you learn from that book. And the same thing happens here. This is, but even, I mean, with the book, it's typically as a passive environment. You can't really do anything with it. But you can, for example, start annotating things around it. So transform it into something a little bit more active, especially if the book gives you a little bit of space to do it. But this environment here is not like that. It's an active environment that actually encourages you to read actively. Because whenever I read code, so we earn our funding. We fund ourselves as a company, and we're doing typically consulting. So some kind of consulting. On the one hand, as I was describing before, working with startups to help them uncover new designs and new domains and pitch to investors before there is a system. On the other hand, we work with legacy systems, where we go in and we work with the teams that have worked with these systems for sometimes 20, 30 years. And we get to tell them things that they don't know about their systems. And this within a short amount of time. Why? Just because this thing works. So when other people do the same things, they can tell things about those systems too. It's not really rocket science. But the interesting part here is that you can also augment, you don't just augment the writer's ability to express oneself, but we also augment the reader's ability to express wishes. And that's an interesting point here. So we're always saying, and that's another big part, is that in fact we notice that the needs of reading are actually orthogonal, almost orthogonal, quite distinct from the needs of writing. They're not the same. But for the longest time, like if you look at the environments, like typically where do people read code? They read in an editor. right? It's an editor, right? It's a tool meant for something else. But those two things, they have other needs. And so that's another part that has to be, that I think is very important, and we have to. That's why we are saying that our goal is to educate. We want people to start having serious conversations about how we are reading or how we are figuring systems out, because there's so much we can do. There's so much we can do to ease, or just in comparison to what happens today. It's not difficult at all to ease how one can go and reason about the system. So, and then it's like up to now, I just talked about some small parts. But if you look here, for example, there's another slideshow about analyzing Java systems, where we just took a simple um, system of 250,000 lines of code, and we have this very simplistic problem, not simplistic, but simple problem, which is, let's find all the deprecated classes and see which of those we can remove and which of them we cannot remove. And those that we cannot remove, what do we do about them? So we give this to people and in workshops, and we ask them to estimate how long it would take. And we give them data about the system. So in this case, there are 25 deprecated classes, and there are 2,500 classes in total here. And people would estimate they would need about 4 hours on average, usually, to go and just read the problem, not solve the problem. Just make an opinion about this, right? And it's interesting because the same problem can be decomposed in a much simpler way. So here, for example, we are seeing, let's find all the deprecated classes. So I can see, okay, look, this is deprecated over here. This is also deprecated over here. So now I'm navigating Java code, right? In the same place where I was talking before about business. And now I'm just navigating Java code, because it's actually, those are not different problems. So here we can find all the deprecated classes that are still being used. So I can see these are still being used. And just to, just for the fun of it, we can actually go and say, well, let's plot those, right? So in this moment, we're saying, these are all the non-deprecated class. This is the deprecated class. And this is a non-deprecated class that is also using it. So I just built a view specifically for this, right? And so now I can see, look, there's a cluster of classes here that I can just remove because they just use themselves, but each other. And this one over here is going to be probably more expensive to remove than one of these two, potentially. So if you think of things like that, then it's easier, right? You just formed an opinion, and we haven't read any piece of code. And it's maybe now at this point when I might click here and then go to the source code to start seeing how I might want to read, how I want to remove some of those. And maybe only now I'm going to read. But before this point, up to here, I haven't read anything, right? There was zero reading of actual text. So what we have changed here was not how the system was built, but how we actually read what exists already. And what we find is also like this idea, what you were saying, like, this idea of have this system, which is a legacy. This is a planet on its own, separated in a different place, and you build a wrapper around it, and you don't never touch it again. Sounds like a good idea, except that until those boxes, these black boxes, they overtake our ability to have any chance of dealing with them, right? And that becomes the problem, because as soon as one thing doesn't work as expected anymore, or like maybe the environment has changed and you really need to go and change it there, then all of a sudden you have a problem, right? And it's a problem that you can't fix. So this ability of being able to drill into something that exists already and still make sense of that, I think is very important, both because of the happiness of developers, but also because of economic reasons. And it's not very often when we can align both of those, right? Both make developers, smile and make them more productive at the same time, right? Those things are usually, they don't come in the package. So, but I think it's possible here, and it starts from us just talking about it, just literally making it the subject of conversation and actively searching for new ways in which we can solve problems which have not really been solved until now. And so what Glamorous Toolkit primarily is, or first thing, the first use of Glamorous Toolkit is to show that there is something to talk about, that there is a whole space that has never really been explored properly. And again, like we just look at the outcome, and the outcome is not good. Like today, we are swamped in systems that we are unable to figure out anymore, and that's not sustainable.
Yeah, totally. But yeah, one thing that I wonder is, okay, so because now there are 1,500 views that they use. And okay, you know what? These are interesting views. Let's put them together. Now there is in Emacs, that is the text editor that I use. There is somebody that created a package to say, okay, take snippets of code. And then every user of Emacs has this their own package with their own snippets that are very useful. So, for example, you want to create a method in Smalltalk, or an object in Smalltalk, you have the whole textual skeleton in there. Now, how do you imagine, say that moldable development goes everywhere and everybody starts using Glamorous Toolkit, but in general, yeah. How do you imagine this? It's going to be Glamorous Toolkit with 1 million default views because everybody kept contributing to a central repository? Or do you imagine, Tudor, you will have your own views, I will have my own views, there are some default views, and then you say, by any chance, say, Tudor, Andrea, you use the same kind of tools, combine them and create something, how do you, if you should imagine, like it's more like a vision thing, what model do you think will happen?
I think so. First of all, like these views, as you see, like we don't have 1,500 tabs here, right? We have very few of them at any given moment in time. If I click on any of these, I have just few tabs. So there's already scoping that happens. Scoping is important, right? So adapting, providing the interesting things that are available or that are interesting for your context, that there's already a filtering that happens here. So even if there are 1,500 views in the system as a whole, you never see all of them unless you query for them. But if you just want to use them, there's already a filtering. So this is one. Second one is, I do believe that there's going to be a time when we will have too many views and we will actually start to have conversations about how do you reason about the usefulness of views. I think there's a whole science that is waiting for us there. There will be a science of, and there will be studies where people will just evaluate the effectiveness of views, and we will want to optimize the kinds of views that we're creating, and we will have our tools, in fact, tell us, oh look, this view is maybe not the most appropriate. This one over here is much more interesting for the kind of thing you're looking at. I also believe that these views are, right now we're creating these views by hand, but in not too distant future, I think a natural evolution will be that these views will be like a completion mechanism. Like you will be looking at some inspectors, and then the tool will infer based on what you clicked on. Kind of think, oh, you probably want to condense these views like that, because this seems like the kind of thing that you're interested in. So maybe would you like to consider these views? So synthesizing views will be a solution for not having to hard code them necessarily. So that will be another one. But I also believe eventually is that there's going to be a need for an editor. So this role of editing, of what views are more interesting than others, very much like how UX today, right? So UX, or designing interfaces, used to be something that happened at the end, right? And now we know that, oh, actually we have to make them part of the development from the very beginning, because otherwise we can't embed those there. We will similarly have storytellers that will be embedded in teams, that will help teams forge stories, that will work for other humans. And they will just, whose skill will be primarily to listen to what people want to learn and work with people to actually build the stories that will facilitate the what people want to learn about the system. So this is how I think. I don't think this is going to be a static field. Like the kinds of designs that you see here, they're just the beginning of it. And so again, like when we started, and if you look at Emacs, right? Emacs was it's a moldable environment from the very beginning, and it was created like that. But it was never really used to the extent, or it was never brought to this ultimate, or to the kinds of to the place where we are at with Glamorous Toolkit, where we are actively creating views every time we have a problem. Like the kinds of customizations, the kinds of they're still plugin based, right? And a plugin will be, oh, here are my shortcuts, or here are some of the views, but I will never have 1,000 views. I will have tens of views. And there's a very large difference between the two, because the way we're using them is really different. It's not enough just to say, oh, some of the views, but then we create tens of views per day. Some of them actually get to be reused, but we create tens of views per day. And so one of the things that we just realized recently, we looked at our Slack, so our chat, and we noticed there that we have shared more than 10 pictures per day for the last years. Every single day, per day, on average, more than 10 pictures, including the weekend. So like if you just take the weekdays, there's going to be more. So you take 365 days, and then we have more than 3,600 pictures per year, per calendar year. So that's a lot, right? And then we said, well, why did we do that? Well, it's because we found that these kinds of views, they actually compress communication. So we don't need to have meetings where we are just going to talk about what we're going to talk and so. It's sometimes enough to just say, here's a picture, and that's my problem. And just describes my problem. If I need help, I'm going to write a picture. I'm going to build a picture that will just tell exactly what the problem is and the kind of help that I'm looking for. And somebody else might say, oh, here's a picture with a solution. And so, oh, yeah, I got it. And then I'm going to do it. Or sometimes maybe we jump in a call. And you will start noticing this on Discord, that there are some people that are sending pictures, and then you will see how quickly they get feedback. Because those kinds of pictures, if the picture is, and again, it's not just the picture about the problem, like the exterior of the problem. So the most interesting pictures are those that describe the inside of the problem, because those are going to facilitate an actual path to a solution very quickly. And yeah, that's another kind of a side effect. And so there will be, I think there's going to be, it's a new kind of a culture. Like it's a new territory where people have not talked about, or definitely not in exciting ways. And now it's going to be exciting to start telling stories about the insides of systems. And I think that we're going to see art in how you're telling stories, very much like you're seeing TikTok or like tweets or so. There will be a culture built around telling stories about the inside of software systems. So that's how I see things evolving.
Yeah, I think you transmitted it very well, because I can imagine now as well, like a probably different approach to software. Yeah, the thing that is very cool is because you in this tool as a spin of this is about storytelling. So even the software itself, even Glamorous Toolkit has a story that is exactly this, to make it not to make storytellable. You know, you can say a story about everything. So that is, I think that Emacs cannot do, because it came from without a vision, more like, or there is a vision, but without a strong statement, say, okay, this is what we care about. And so
I think no, I think that Emacs solved the problem, which was an important problem at its time. Like, and editing was a big problem. It was not a solved problem, right?
Mhm.
It's just that we are here. We just see this is a new problem. Like the reading is different from writing, so that's
Yeah.
why we're just having this different. Yeah.
Yeah, totally. And yeah, that I have also a question, but then did I? Yeah, but yeah, indeed, that is the cool thing that I'm imagining is this idea that, okay, if you give up the possibility to create, because picture is only one way, right? If you are communicating via pictures, this is because at the moment the tool is making simple to do that. If
Mm-hmm.
I make the tool, make it simple to create 3D holograms things,
Mm-hmm.
I will start looking at the thing,
Mm-hmm.
and we have already seen that the machine can make this easy. For example, yeah,
Yeah.
recently yeah, but yeah, anyway, so and if you leave the liberty to a person to create a video game, for example, out of a software system, and so
Mm-hmm.
you do sort of like this archaeological exploration of a software system, all of a sudden this boring for loop and stuff can become. So, for example, there is a video game Factorio that is taking a lot of people interest is functional programming as a game, and people are starting compiling programs to the game.
Very
So
cool.
they write a software and it becomes a so that is a view really. That video game is a view of software of
Mm-hmm.
a so it's a very step away. As long as the tool allows to be free in that way, you can open up a world of imagination that people have in chasing themselves that is not expressible at the moment.
Yeah.
So that is a very great advance if yeah if it happens and at least if there is the possibility to do it. But for example, one thing that not it's not clear to me. Um, do you imagine like okay the, what I'm saying is like if I'm an Emacs user that I've been using Emacs for 20, 30 years of my life, no, now uh, as all the sustainable things, it cannot be like, okay, you know what, drop Emacs, use Glamorous Toolkit because do you imagine like all these people that have all this tooling that they can integrate it in a you know like in a nice fluid way. So, like for example, I say, okay, until this bit I am familiar doing my to-dos and stuff, but all of a sudden I translate them in a Glamorous Toolkit and back into, like to create a cycle. Would you imagine something like that? Or
Yeah. So one of the things that is it's not maybe entirely obvious, but I think will be obvious in shortly, is that Glamorous Toolkit is so it's not just an environment for Smalltalk for Fire. It's in fact it's a client-side technology for creating projections about software systems written in various types of technologies. So from that perspective, just like Emacs, right, is pretty much an environment where people are going to accommodate different kinds of data sources and then edit those, and navigate and edit those. In our case, kind of doing the same. So I, one of the things that I think is detrimental is when you're packaging the experience with the data structure of the that you'll be that you'll be using, because like today it's quite clear that there's not going to be a single data structure that will like there's not going to be a single language, there's not going to be a single data structure that will win anything. There's going to be many always, but there can be a language with through which to go and understand those. And what Glamorous Toolkit is a language through which we decompose these explorations, specifically the reading part, but we're more increasingly are showing how this one applies to writing as well. But I expect there will be other languages. People will build other languages, just like the same thing that I hope maybe 30 years ago there were just a handful of languages, or maybe a few hundreds, and now we have thousands. Similar things will happen on the UI level as soon as people will see that this is a language. So Emacs was or is a tool as a language, and nicely integrates with the underlying implementation language, which is Ellipse, right? And Glamorous Toolkit is another one. I think that they can coexist, and neither of them is the end of the conversation. So that's how I see it. But we will be continuing to explore the space, and our goal is to make people, dream more than they can dream somewhere else. So, and then we'll see what people choose.
Yeah. Yeah, indeed. I think it's neither a matter of choosing. It's proper just it's a way of expressing yourself. It's like you can be an artist and you express yourself with aquarelle, or you can express yourself with oil paint or with a drum kit. So like it's and surely each of these has a reflection on the world and on the systems around it is slightly different. So like your neighbor will be like don't want to hear the drum kit, but they will like the paint. So for example.
Yeah.
So it's but yeah, very very interesting, very cool. Yeah, I got too many questions, so I'm not sure if we. Let me try one because it's a huge problem. I'm scratching my head from a while. So I think I will use this as my last question so that I don't consume all your life. Say that I'm a product owner. Okay, say that I'm a business person. Now, my drama is, if I'm a technical one, let's say, my drama is that, okay, I know that at some time ago I asked the development team to implement this feature, but I don't really know if I have all my system in front of me where this feature was implemented. Like say this area, like to have an idea so that then I can go to my friend architect or developer and say, look, something broke there, so don't waste your time looking around because we did it 10 years ago, but it's these two components that you have to look. It's gonna be somewhere, like to facilitate. And the fact is that every time we put these stories in other systems, so like for example, the requirement of the user typically goes on some management system of stories that then has a tag over there, and then there is a tag in the commit maybe, but there is never a. In Glamorous Toolkit, there is you have a way to do these kind of things. Like we have already spoken that it's all a story, but also historically you maintain these stories somehow in a way that you can retrieve them if you.
That's the thing. So it's the same as with with querying. So let's say you have a query about a data. You have a database and you want to write a query. So now there are two ways to do it. There's either say, oh, here's the complete index of all the queries that have ever been triggered against this database, which is an interesting source of information. But then there's the other one, which is saying, well, let's learn the language of the query language and map my query, what I have in my head, onto a query that the computer can understand. And that's a skill. And that skill doesn't necessarily depend on the amount of queries that have been created. But you can combine the two, right? So you can, for example, if you in the same environment, you would have a place to say, actually, can you give me all the queries that have ever been triggered on this table? Then all of a sudden you say, wow, that's like an interesting thing, right? It's like now I can have a much more a subset of those queries that I can go and reason about or look at. The same thing happens here, right? So when I was talking about the problems from like how do you find out what kind of shortcuts exist? So I took one way, but then sometimes you have other ways. Like, and for example, if you notice on Discord, when people are asking, sometimes we're just saying, oh, here's a query. Go and find it yourself. Here's how I found it. Here's the path that I took. And there's like a graph, like the system is a graph. It means that there's no single way to go through that graph. There can be many ways to go. It's like a map, right? There's no single way to go to Rome. Uh, there are many, right? And depending on where you are, but depending on your preferences, depending on what you know, and yeah, so and this is how you'll find your way. But the essence here is that finding ways through a landscape is a skill that you can build over time. But the interesting thing here is, and then the reason why we're showing many different kinds of use cases and many different kinds of problems that we can solve uniformly with the same environment. The reason we're doing that is because we want to to ensure people that there is the promise is that if you're going through the process of learning all this, at the end you will be able to cover your area. Because so for example, if you the problem today, right, is that you say, wow, the way I reason about my events in my in the production is going to be completely different from the way I'm going to reason about architecture, which is going to be completely different from the way I'm going to debug something, which is going to be completely different from how I will, I don't know, reason about an API. But what if they're not that different? What if there is a way to start learning how to navigate through all of those by just learning fewer things, a language with which you can start decomposing more and more problems? Very much like how you would not so much like, like there used to be a time when computers were dedicated to a specific set of problems. And then somebody said, well, we're going to build a generic computer, right? And it was like, wow, but that's like a crazy talk, right? Who would ever need, or like, how is that going to be possible? And then it turns out this is possible, right? So when you're doing that, then all of a sudden it's not important how specialized you are. It's much more important to learn how to transform this genericity or generality into specifics. And there's a skill there, right? And this is where programming happened. Because now you could map whatever you thought into a program, and that would then solve your problem. The only thing here is that we stopped and we do not apply programming as a way, like the problem of reasoning about my system is also a programming problem. We're today treating it as if it's a tool, a dedicated tool set problem. And that's the limiting problem. That's the limiting factor. Instead, we should go and stop obsessing about indexing every knowledge we have, because that never worked, right? Yahoo tried to do that for the internet. It didn't work out, right? The thing that won was the search one, right? And search is just a box. Whatever you put in the box, that's what you will get out, and with all the other bias that the technology will give you. But but the point is that search is much more of an interesting skill to have than the ability to go and index everything, and so that you can optimize the retrieval. So, of course, the truth is somewhere in between. But that's how I see the problem.
Okay, yeah, I get it. So yeah, it's more important. Yeah, it's sort of remember me sort of category theory that they really care about pattern matching. So you have a bunch of points and connection and stuff, and you just try to look for the pattern that you are interested in. Because at the end of the day, you can think of Glamorous Toolkit, something like that. You have the view that is a pattern and say, okay, if this match, now I apply this pattern, you have to decide which pattern you want to apply, but this matches. And so that's why I show it in the window, and so it's all about that. So you say, okay, reality is just a matter of scattered point around and pick the pattern match that best suits you, and that helps you progress in whatever way you want to go. Yeah, I understand. Okay. Yeah, it's very enabler. It's very nice way of approaching.
And so maybe to summarize, if you're a product owner and you want to go and improve your ability to go and answer your questions, you have to go and invest in this skill. Now, will you be the one having that skill? Likely not, probably not. But somebody around you should have it. It's very much the same as, like if you wanted to have your system to be more testable, you have to invest in the skill of testing. If you wanted to have the ability to deploy faster, you have to invest in that ability. This is the next jump.
Yeah,
Projecting views based on demand, based on what people want to see.
Yeah. Very powerful, very empowering. Yeah, I like it. Yeah, it's fun. Yeah, I will surely look more into Glamorous Toolkit and be a bit more active on Discord and see how can I learn more.
Excellent.
Yeah,
Well,
but
thank you
thank
very
you.
much for the conversation. And
Yeah.
I would like to also thank everybody watching. Thank you for your time, and please do join us at gtoolkit.com, and do join the conversation. We have an open Discord channel. You can find it at gtoolkit.com/contact, and let's have that conversation. Thank you very much.